So let us first understand how the laser works, or the physics of lasers. We have learned that every atom is made up of electron, nucleus. So the nucleus is in the center and the electrons are rotating around the nucleus in different orbits. So by if any means the electrons are stimulated or energized, they'll move in a different orbit level higher than the energy state. This electron is an unstable state, so it will again come back to its original orbit and its original energy state. So while coming back to its original state, it will release the energy which it acquired to get stimulated. This released energy is in the form of light, which is also called as a photon. So when these photon or the energy is released, this is in a constant, if it is in a constant or continued process, there's a light amplification. And these amplified photons are then passed through another semi-reflective mirror on the other end to give a laser beam. Now the laser system has three essential components, that is the lasing medium, which may be in a gas stage, crystal stage, or a liquid stage. Then there has to be a source of excitation which will cause the electrons to be stimulated or energized so that they release the photon. So the source of excitation to excite the lasing medium may be flashlight or electricity or diode, etc. So mostly we are running the lasers on electricity. Third is the mirrors, which reflects the excited photons back to the resonating cavity containing lasing medium and then into a semi-reflective mirror through which the laser beams comes out. Generation of the laser beam is discussed earlier as an excited electron coming back to its normal state, and its energy is released in the form of light or photon. Now if this released photon is reflected back again to the laser medium by mirrors, it will excite another electron, and this in turn will release another photon, and when it comes back to the normal state, this will result in a continued amplification and increase in the number of photons, and hence the light amplification. Now as I said, this amplified photons will pass through a semi-reflective mirror to the other end, which will be coming out as a laser beam. So you all can go through the PDF file and notes and get a better understanding. Now each emitted photons have a specific wavelength or a specific colors. We have seen in rainbow, like there are various colors due to various wavelengths. So these photons which are emitted have various wavelengths and also colors that depend on the state of the electron energies and the photon that is released. Now two identical atoms with electrons in identical stage will release photons with identical wavelengths, right? Properties of laser light. Now what is the difference between a normal ordinary light which we have at home and this laser light? Now laser light, unlike our normal lights, are coherent. That is, they are all in the same phase. Secondly, they are collimated or unidirectional. So they travel in the same direction and are parallel to each other. Third, they are monochromatic or of the same color. If they are of the same color, they will be having the same wavelength and the same specific color. Let us see the electromagnetic spectrum. All the electromagnetic rays have the following properties. Now, We have learned this in physics also before, that electromagnetic rays have frequency and wavelength. So what is frequency? It is the number of waves per second, right? And wavelength is the amplitude of the wave, that is the distance between the two crests of a wave. Frequency is always 1 upon wavelength. The primary wavelengths for lasers include ultraviolet, visible and infrared regions of the electromagnetic spectrum. Ultraviolet radiations are the wavelengths between 180 to 400 nanometers. Visible regions are 400 to 700 nanometers and infrared regions are 700 to 1000 nanometers. Now this wavelengths you have to keep in mind to treat different cosmetic problems of the skin, because every filter has different wavelengths. So you have to choose the proper filters with proper wavelengths to treat the specific cosmetic lesions. Like in melanic skin lesions, you have to use above 800 to cause damage to the melanins. And for blood related or HB chromosomes, you have to use 400 to 700 nanometers. So the ultraviolet, visible and the infrared ranges of the wavelengths are referred to as optical spectrum. So that we have seen in VIBGYOR from violet to red color, those have different wavelengths. Now this is all we can see, so it's an optical spectrum of wavelengths. Units used in lasers are energy, which is measured in joules, and fluence, which is also energy density, so these two factors we have to set on the laser to target a specific area of the skin. The laser energy is derived to a certain spot measured in centimeter square. Now again, third factor is the power, which is also measured in watts. So energy, fluence and power, these are three important parameters while what we use in lasers. The total amount of power delivered to the skin is in one pulse is fluence pulse duration per millisecond. Therefore power in watt is measured in watts, fluence in joules per centimeter square, and pulse duration in milliseconds. For example, if an energy derived is 50 joules, spot size is 10 millimeter, that is 1 centimeter square, and pulse duration is 30 millisecond. So we'll understand exactly what all this means. Spot size is the area through which the laser beam comes out of the machine. Pulse duration is the duration of the period or the period for which the laser is acting on the skin. And the energy, so how much energy of the laser are we giving to that skin, is the joule, or it's measured in joules. Energy is measured in joules. Fluence in relation to wavelength. Longer wavelength laser will require higher fluence but create less skin damage and will be less absorbed by the pigmentation. Now, so fluency is opposite to, I can say it's inversely related to wavelength. Longer the wavelength, lesser is the